So welcome everybody to this workshop. The workshop with the name Future of Drives. It's a big name, but we want to talk about the key technology trends for the next few years. My name is Joachim Hanke. I work since 24 years for this great company Lenze, and we want to take time for that to show when we are talking about future about automation, about machines, how to make a machine better, how to make a machine more efficient, then we are talking about innovation. And innovation comes not from alone, innovation comes from you as a customer, from you as an end user, and for sure also from us. We are responsible for the automation and drive motion profiles. So put that together and then you have really a good innovation, and we are doing that at Lenze several times in a year. So we take innovation days together with our customers and talking one day about the future trends. So what's going on in your market, in your machine, what is about your competition, and we bring our experience in, and we found out at the end, Lenze is working on 7 technology trends. Here you can see we are starting with the digital engineering. It's a big point. So that means at the end that all what you are creating in the designing, in the dimensioning, in the commissioning, in the build-up, and at the end in the production phase, you are using different tools, and these tools must work together. That every material, every information is get not lost. So this means digital engineering. If you go to production, then in a modern factory, a smart factory, then you have IoT solution and digital services. So all information what you get from your machine must be visible for the maintenance, for good maintenance. And if you have this kind of networks, this kind of infrastructure, you are for sure dealing with cybersecurity. You must save your production. And maybe you know there is a new European law is coming, a cybersecurity law, end of 2027. So we have for our components here, our drive components, for example, many things to do that we are cybersecurity safe. And this is also for you as a machine builder end user. You have to make your infrastructure cyber secure. And the next is the openness. For sure, we have to work as a drive supplier, motion supplier, directly under different PLCs. It's not only Lenze, it's Siemens, it's a back office, everything in the world. So we must be open for that. And the next point is usability and user experience. Means to build a good machine, to build a good production line must be smart, must be easy to use. And this is also one key point. We are working very strong with our customer how to make a machine easy to use. And you know, in the future we have not enough people, not enough knowledge-able people, so that must be optimized in how we work together with the machine. Sustainability for sure is also a big point, to save energy. So energy cost reduction is a big point, and at the end the 7th point is the scalability and the flexibility for your machine. So these are the 7 points Lenze as a drive supplier is working on, how to make a machine better. And I want to step in a little bit more in detail what is about digital engineering, what is about IoT solution and sustainability. So we have not the time to go to all the 7 points, but I want to have a deep dive. I want some details about this part, and here you can see my content of my presentation here. So I will make an example about digital engineering for the automotive industry. They are very innovative in this topic, and then we go to one machine. What does it mean from the concept phase to the production phase? Then we have a look in a warehouse, in an automatic warehouse. Here is enough place to sit if you want, at the front. So we want to have a deep dive in a warehouse and how we can see what is in a modern warehouse, what we are able to see to protect or to make a predictive maintenance. And at the end, we want to talk about sustainability. And there's really a big point coming up in the next years, and this is DC technology. So how we are able to deal with DC technology in the future. This is a big point. and I want to give you a short information about that. Has big influence. So let's start with automotive, go to digitalization and digital engineering. If you see this kind of fancy cars here car manufacturer is working to develop a car totally digital. So you can see in digital development they have all modules available, they put the things together, and this is something what they make a digital twin, digital prototype for sure, and a digital testing. You can imagine if you build a car, you can't build only prototypes, this takes too long. For sure you have to produce some prototypes for crashing and for the certification, but at the end everything is in the digitalization, and if you go down then to production, not to build the car, so to the production, then everything in a modern factory of a car manufacturer is connected with the Ethernet-based communication channel. Because they want to use data, they want to use what's going on in my factory. Are we efficient enough? Are we safe? Can we produce? Are there some upcoming failure? You need this kind of Ethernet-based communication. And for sure, if you have that, then you comes automatically to the smart factory, so data handling. How does it meet? What are the key elements of the data? And then agile product system and a streamless digital process chain. So this kind of automotive manufacturer, we are working close together, and they really push us hard to build a better solution. Now we step in one machine. Maybe you know that this is a kind of crane, a stacker crane, which moves material from A to B and bring it in a warehouse. And that's like a car body, something like that, a big machine. So our machine builders, our customers make a concept, how to build this machine. They make the engineering supported with our tools for sure, to find out the right components. Then they build this machine, make the commissioning, and then goes to the end users for sure, because this machine is running at the end user. And what is the main point is here, you can see different people are working on this tool shed, different people. So here you make the development, and then you make the first commissioning, and then in the production you have also different people all over the world. And the main point is there are different tools where they work together, and we don't want to lose different information. So here you can see a couple of informations about what's going on in the engineering process. We are using different tools, and then if it's not connected, if these tools are not working together, then you lose information, and you have to bring this information hand by hand, and this is a failure what you can have. And in the future, well, what is the dream behind is everything is connected, and that you don't lose information. If we step in now, the customer comes to us and say, hey, I want to build a new very fast stacker crane. So they know what kind of loads they have to transport, what kind of length of the aisle they have to deal with. And they ask us, hey, I need a drive, a very efficient drive. And then we took our tool in and makes a dimensioning of a very efficient drive, like an inverter, like a servo inverter, like a servo motor, something like that. And then you can see also our tools, which is connected directly to the customer, is that we make the dimensioning for sure, that we have the topology behind, and then automatically comes the documentation for your customer. We can use automatically the E-plan and CAD data to make the drawings, and you can also handle with CBQ, so you can offer or order directly this kind of component in SAP in Lenze. So you don't need different departments for that, and this is only digital. And there's another big point. The big point is, if you make the kind of dimensioning, you know what kind of motors you are using, then you have some parameters, because you know the profile, the motion profile, what you want to use. We can export that, and this is part of your PLC programming. So this is one tool, this is a part how we're thinking about to save time, to reduce complexity, and it's a cloud-based solution. That means if the customer is working on that, we can every time step in if we have the access and optimize it together with him. So it doesn't matter where he is. So at the end, so we have also for these different areas, for the different people, different tools, but everything is connected. No? And that's a key point. I think this is a digital engineering process where no data losses you have. No? So this was the step in the digital engineering, and now we want to look. Now we want to look in an automatic warehouse. What does it mean if we look in a warehouse? So this kind of warehouse where we store material and have transport of this one, for example, 600, 700 drives are installed here in this kind of warehouse. Our customers like Stöcklin, Vitron, TGW, Vanderlande, Dematic, all the big names, they are built this automatic warehouse. And they are responsible for smart production, right? So they make a material flow very efficient. They make the monitoring, the optimization, the plug and produce. So this is the part of this key customers. Lenze, what is Lenze doing? We are responsible for the smart machine. So with this kind of stacker cranes, conveyors, AGV, something like that. And if you're looking in a digital service, digital engineering, digital solution, then we go with our part here in the asset management, remote maintenance, condition monitoring, and predictive maintenance. This is what we are doing, no? And then providing to the, for sure, to these guys here that they can make a smart production at the end with the application. Now we step in a machine. So here you can see a real photo from a stacker crane and the conveyors. And if you want to have a modern factory, a modern warehouse, then for sure you need a modern infrastructure for that. No? So here you can see this kind of crane, this one here, has these 5 axes here, driving, hoisting, load handling device, fixing, something like that. And then this data, if you want to make it digital, if you want to monitor something, then you bring this data out via Ethernet-based communication, bring it to a data store area. You have some software there, and then you have the dashboarding, Grafana dashboarding, and then you can bring it to the shop floor, to the maintenance guys, and make it visible. For sure, it's not so easy. No? So we've done that by our own in our new warehouse. How to deal with IoT guys, and also the security. This is it's also a learning curve, no? For that. So what is essential to have an efficient and very visible monitoring? You need a modern frequency inverter or servo inverter, doesn't matter. So this one here. And you need, for sure, you need this kind of process data. This is the key element to make predictive maintenance at the end. No? So for sure, this kind of motor frequency, motor current, something data must be with a high resolution oscilloscope function, otherwise you don't get data. Good data, I would say. So I will make one example. If we now look into this crane, and we are looking for this guiding wheels, this one. So this guiding wheels had the task to move this crane very stable in this direction. No? Not this one, not this one, very stable in this direction. And after a while, this kind of wheels have some problems. It's also normal after a year, after 2 years, something like that. And at the end, you see some of these these flat spots. What does the flat spots are doing? So they bring vibrations and shocks, and this can also come from because this construction is not very accuracy, or the pressure of this construction here is too high, something like that. And you can see it. You can see it. Oh, this is not connected directly on our motor. This is connected only in the mechanical part. But we can see the shocks and vibration in our current, in our motor current, if you know where to look. No? So you see it. And here was a typical service, and they found out, oh, this flat you may have to change. No? And then ask our maintenance, okay, this can be a problem in the future. Yes, this can be a problem. No? Okay, and then we analyzed, because we had the data, when does it start? And we take some filters in and knowledge in, and then we could see if you know where to look, that this kind of problem occurs 40 days before. No? And this is kind of predictive maintenance. If you can see what's going on in your machine, you can see, and then you can plan a service. No? It's not waiting up to the date where the machine is stopping or have a failure. So you can plan a maintenance topic, a service topic, and this is a key element. And you do it with the standard components. You don't need an external sensor or something like that. We see it with in our high accuracy oscilloscope functionality. We can see this kind of topics. No? So with a modern frequency inverter, you are able to do that. No? Good. Comes to the last point. What I want to present is sustainability and flexibility. So one part is the topic of decentralization. So how we can make a different solution with less components. And I'll give you one example here. You see a truck load and a reload application. This is an application very common at the door in the warehouse. A truck is coming, and this kind of telescoping conveyor goes inside the truck, and then the guy who can put the boxes on the conveyor here, or to reload or load the truck. And for that standalone machine here, you need this kind of control cabinet. So with a PLC and with the switches and clamps and connectors, frequency inverters and everything. So this part is here on the integrated in this kind of telescoping conveyor. So what is the story for decentralization is you can do it in a different way. If you have a frequency inverter which is able to work without a control cabinet, then and you have the PLC functionality inside because it's not so complex here, we can do it with some three. For sure you need 3 frequency inverters for that. But you can do it very decentralized with I/O links. You have the connectors and everything, so you can do it without this kind of big control cabinet, no? Without a big PLC and blah blah blah. So you can reduce components and at the end also more price optimization, something like that. Only one example. So we have this component here on our booth. You can see it, and we can talk about that if you have interest in that. The last point I want to mention here is a DC supply. So today we are working on the AC level for sure, and the DC technology will come. And big customers in the automotive industry are asking us, hey, we want to use in the future only a DC factory, nothing AC. So what does it mean for us? No? So you can see you have generative, you have the solar panels, you have the wind turbines, and you have energy storages. When you are able to do a factory completely in DC, so for this machine center, conveyors, robot system, lift application, everything in DC, this is huge of benefit for reduction of cables, for reduction of the in-feed power. And I will show you what does it mean on the example from the warehouse what I shown before. So if we now look into this warehouse, today it's done in 400 volt 50 Hertz for sure. Other components are not available. So then we make a calculation. What does it mean if we go completely in DC technology, if the products are available? And therefore we make a consumption about the energy analysis, and we add all the motors and installed base, and you can see from this warehouse here around about 700 drives, 650, 700 drives, many small drives for the conveyor for sure, and many bigger drives here for the cranes, for the strong cranes. 560 kilowatt installed base. And you see when you make an analysis about 1 week, what energy this complete warehouse is using. See the weekend here. And then there is only a peak about 200 kilowatts, something like that. And this is the normal power what you need as the complete infeed for this warehouse. In average, if you only see this one, you need only 6 gigawatt. For sure, you need the peaks to make the acceleration and the speed and everything. But you have also enough of generative power here, which you don't use. No? You don't use. No? So now comes to the last point. If we are able to do that with a DC bus and energy storage, then you can reduce this kind of peaks here from the infeed, from the infeed power station. Reduce it dramatically to 60 to 80%. For sure, you need this peak topics to have this acceleration, but this comes from the storage area, from the energy storage topic. No? Therefore, you need this kind here, no? Yeah, with the storage. Then you have a 100% energy exchange, so you don't have this kind of break resistors. You bring the energy directly back to another machine or in the energy storage. So this completely topic is storage. So we have, and then comes the next big point, less kappa. So the cable what you are using is dramatically slower. And you have, and then comes the point to us. We can also provide in the future smaller drives because you don't need this kind of AC topic. No? So are we ready for that? No. No. Are we doing that in the future? Yes, for sure. This kind of adventures is so big, and the end user like automotive is pushing us so hard, but they can only do it in a DC factory if there is not Lenze alone, as you need all other components there in the control cabinet. No? Also other supplies like Siemens and so on. No? So they don't want to deal only with lenses for sure. No? Maybe it's better, but it doesn't matter. So this is, I think, a big topic. But for us as a system, as an automation and drive supplier, is that we have to double our portfolio. We have an AC portfolio and a DC portfolio. And this is a big investment. No? And you can imagine all this kind of AC solutions is supported by the normal planner, so they have all the documents available, but makes this warehouse in DC. No? You have to create new documents, everything. So there is not only that an end user decided want to have a DC and okay, they can use Lenze because we have a product. The completely network must be also on the DC level. I have to stop now. Oh, okay. It's interesting. So it's really an interesting story all about. So we are only talking about some slides here, no? But you can imagine if we want to talk about all the 7 elements with a deeper dive into these topics. This is why we are doing this innovation days. Innovation with key customers. They open their mind, and we open our view, and then we create hopefully a better future. No? A better future in efficiency, a better future for products, more output for your customers. No? So if you want to have additional conversation about that, please come to our booth. No? So I'm glad to talk with you. So we have this booth 7.0 here, and have a nice day. I hope this was interesting for you.
Yeah.